Okay, so hello everyone. Am I audible?
Yes, sir, we can hear you.
Okay,
Yes, sir.
so okay, thank you. Okay, everyone. Good evening to all. I am Shiv Prakash.
Yes, sir.
Okay, thank you. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. I am here to take in our live iteration classes like assignment basis to solve the problem solving session for the course of design of photovoltaic system. And the course uh, taught by the Professor Alumanan sir. Here the main course name is the design of photovoltaic system. It means all of the lecture depends on the PV system only. I think all of you know about the PV system and working a PV system, how it work. Mainly a PV panel, all of you see in the PV panel also, and you can store the energy in your battery, or you can use like a inverter to generate the electricity from PV panel, PV cell to the grid. Also can transfer the power to the grid. There are a lot of the application of PV panels or PV cells. Like mainly number of cells are connected in series and parallel to make a PV panel, and it is basically works on the principle of the PN junction diode. All of you know about the diode and how it will work. Know about this diode circuit. If you take a circuit, okay, in this system, give supply to a diode. This one the voltage across the diode VD. This is the current of ID. And all of you know about the characteristic of diode like this. This one is cutoff voltage. If voltage is positive, current is positive. You know about this one. This terminal voltage is plus minus. This one positive. Current also enters from positive terminal. Then it will work like a sink. Yeah, this is the power dissipation. If same thing is coming in the reverse of this one, then it will deliver the power. If same type of, suppose some another circuit or some other system is applied to the reverse direction, current will be reverse. This mean it means in this region will be have power generation region. From the PV panel or PN junction diode, same thing. If you want to take energy from them, then you should this auto system you have to operate it in the power generation mode. It means current should be supply from this. Any system, if you take this one like a system 1, this one will be system 2. If a power voltage, if voltage is positive and current is entered into positive terminal from the positive terminal. current enters from the positive terminal like that, this will be positive, negative, current enter like that, this one in positive terminal, then that system known as the passive system. This system will power dissipate only, it can't be generate the power, or is known as a sink, like that it work like a sink. Same time, this will be in this system, current enters in negative terminal and in positive terminal the current is leaving. In this condition, this is work like a source, and this will be source, this will be sink. Same thing if current is reverse direction, then this will be working like a source, this will work like a sink, like so. But in a simple diode characteristic, you know about this one, a voltage across it, if you give us some voltage across it, then it will block some voltages. After some time, after it reach this voltages, current will be flowing through it, but in non-linear in nature, it's not linearly like a resistance or resistor, inductor and capacitor, it will non-linear current. Same thing, I used a PV panel. PV panel also have a PM junction thing and a depletion layer between them. When sunlight is on the sunlight, it will generate a voltage like a depletion layer between them have some voltages. Same voltages are occurring here also, and this is known also no silicon. For the silicon, this will be a 0.6 volt cutoff voltage of diode. Yeah, I have recording this one and I uploaded in YouTube, and I give you link of this one also in next lecture. I will give the link. Don't worry. And I think you have also provided from the NPTEL. Then a PV panel, sorry, a cell, a PV cell, photovoltaic cell, are represented like a current source and a diode. And anyone have some doubts? Previous two class I did not get
Good evening, sir. I
yeah,
am Nofil. Sir, can
yeah,
we get recorded classes on this class?
yeah. Definitely you get that. We'll
Yes, sir.
get.
Because due to some time issues, I was unable to attend from the start. So, can I get this recorded class?
Yeah. You can definitely. I will get. I will give a link in next class. If you
Yeah, okay. Thank you,
ask
sir.
same thing, I will give you
Thank
link
you, sir.
of this video. Don't worry. And same thing I will upload it to YouTube also. You can watch there. Okay, thank you. A PV cell have work like a constant current source and a diode, a PN junction diode connected to parallel across it. That combination is describe the nature of the PV cell. Like this, a current source and a diode. This is the equivalent circuit. You can see this one, a constant current source. This will be depending on the insulation of light. This will be diode, some diode current ID. This will be IP. This is the terminal voltage of the PV panel. You can say PV photovoltaic cells. This is representation of the PV cell or PV cell. A simple PV cell is represented like that. It will be ideal in ideal cases. In practical cases, some resistances also is there. But in I talked about the ideal cases. Then you can describe this one is the characteristic of the PV cell. What is the characteristic of the PV cell from this one? This will be the constant current source only. Diode have you know about this characteristic of PV's characteristic of the diode. Then I can represent this one like a constant current source IP. Same thing a diode current, it means you can say this one IPV is equal to IP minus of ID. IP minus of ID. ID is the current diode current. IP is the insulation current or you can say photon current. Photon current is which one is generated from the PV cell. Photon current minus diode current. Then you can subtract the diode current from this one ID VD. Sorry. Then what is the main characteristic of the PV cell? After subtraction of this one diode current, we will get the VPV IPV characteristic. You can see here this is the IP maximum. So this is the 0 at that time, same time. From here at a 0 point, diode current is 0, IP is maximum, and IP is maximum. Like that, you can say this one. At some time, somewhere this is the 0 because of the cutoff voltage. If exceed the cutoff voltages, then you can uh, increase the current through the diode. In that condition also this will be a same current flowing. After that this will be a increasing. A diode current increasing, it means subtracting from the photon current, there will be a decreasing in order. This is decreasing at some time. At this peak, it will be a 0. I think this will be like that. In this characteristic, this will show as the like at a 0 current. You know about that at 0 current, it means the open circuit. Then this will be a open circuit voltage. At a 0 voltage, this one at the 0 voltage, it means a 0 voltage means short circuit. If any circuit, if you take any circuit like that, if you short this one, if you short two terminal, this voltage will be a 0 voltage only. At this point of this one, it will be 0 voltage. If you reduce this one, then this voltage is different. V, if you R, I, okay, then this voltage is V output is equal to V minus I into R. But if you short this one terminal, two terminal, then this will be a 0 because of two terminal are same. That's why this will be a short circuited. If this is short circuited, then at the short circuit condition, current is flowing. That current known as a short circuit current. Like that. This is the PV characteristic. But this circuit is represented in the ideal cases. But in practical cases, this will be not the same. some of the resistance and series and parallel resistances, shunt resistances are also there. To including of this one, then you can say as equivalent circuit of the PV cell is a current source and a diode then a shunt resistor and a series resistor. Are such shunt resistor, series resistor, so VPP, IPV. This is the equivalent circuit diagram of the PV cell. In this condition, you can say the total current, a photon current is total current ID plus ISH shunt current plus a PV current final IPV. Then what is the IPV? In our panel, PV cell current is IP minus ID minus V plus I into RS. This will be the IPV. Sorry. Let me do and later IS. First to this one. Photon current minus diode current minus shunt current is the final PV current. This is the known as simple a PV cell, and the PV cell represents like this box only. This is the PV cell. The number of PV cells are connected in series and parallel to make a panel. Deepak, please turn off your mic. Please turn on. If you extend, if you extend this one to know about the diode current, what is the diode current? Shunt current, you can calculate here. Then what is the voltage of this one? This voltage is this voltage plus the voltage drop between series resistor, and this will be VPB plus IPV into RS. This voltage is this one. Same thing you know about diode. Sorry. Yeah. Your diode current flow is this ID and the voltage across this is suppose VD. Then what is the ID? Or diode current. Diode current depends on the reverse saturation current into e to power V d divided by NVT minus 1. This will be any diode current flowing through any diode. This will be the reverse saturation current. It will depend on the I naught temperature T power m e to power minus VGO. VGO is the band gap energy, forbidden band gap energy of electron in electron volt Parasilicon, I think 1.16 to 1.2, like that. When n is the ideality factor, for silicon it will be 2. Q and Vt, Vt is the temperature coefficient equivalent voltage, like Kt by Q. This is the Boltzmann constant. This is the temperature in Kelvin. Q is the charge of electron. All of things like that. This will be the voltage across the diode. This voltage represent that how much current is flowing through the diode. If you putting same thing in this formula, then okay, you will get the final current of this one, IV minus ID, same thing, I naught into voltage across it, same voltage, this one voltage, which one across this one, VSH. Shunt voltage is same as the diode voltage, and shunt voltage is VPB plus IPP into RS. Then e to power VPB plus IPB into RS divided by NBT minus 1 minus shunt current same thing, VPB plus IPB, shunt voltage cost on resistor and divide by a shunt resistor. This will be the final equation of PV cell current. Okay. Then what is the short circuit current and open circuit voltage? Two is the most important thing in PV cell. Then how calculate the short circuit current and how to calculate the short circuit voltage. I reduce size of this one. Sorry. I think it's a little more small. Okay. I will increase this one a little bit. To find the short circuit current, what will you do? We have to do this one will be short circuited. If we do terminal will be short circuited, we will get the short circuit current IPB, ISC. Same thing I can do here. This one IP, this one ID, shunt resistor, series resistor. This will be short circuited. Then this current is flowing with short circuit current. It went like IC. and voltage VPV will be 0 because of short circuit. I saying previously also, if you short circuit a two terminal, then their voltage will be 0. That's why VPV will be 0 at this time. Then what is the current of this one? IPV already calculated, like IP minus of ID. ID is equal to I naught e to power VD. VD is VPV in previously, plus IPV into RS divided by NVT minus 1, then minus of RS shunt current. Shunt current is same VPV plus IPV into RS divided by shunt resistor. But in this case, VPV will be 0 and VP will be 0, this will be 0, VPV here also, this will be 0 also. Then this current will become short circuit current. IP minus of I naught, this will be 0, it means e to power IPV into RS divided by NVT minus 1, this will be 0, and IPV, oh sorry, IPV is same as short circuit current. And same thing, this will be also short circuit current. The this is talking about a cell. A cell voltage is open circuit voltage maximum is 0.6 volt only. A short circuit current is short circuit current. The current is also less than a cell. A number of cell are connected in series and parallel to make a higher voltage and higher current rating. Same thing, a series resistor is very less in milliohm and a shunt resistor is very high in this condition. That's why we will neglect of this one also, this term, because of shunt resistor is very high in respect to this, in respect to the series resistance. Same thing here also, e to power minus of something, it will be times to 0, then e to power something 0, like 1, 1 is 0, you can neglect this whole term also, it will be very less. Then ISC, you can say directly proportional to a photon current, and photon current is directly proportional to the solar power as insulation, we can say insulation, solar insulation. A short circuit current is directly proportional to the photon current. If insulation is increasing, then current will be increase, and insulation is decreased, then current also decreasing. It will directly proportional to this one. Okay, same thing you can find open circuit voltage also. For the open circuit voltage, same terminal you get the to find the open circuit voltage, get a two terminal is open, open circuit, this will be a voltage across this one will be a VOC, VT will be VOC. You can say VPV is equal to open circuit voltage. Current will be, what is the current? IPV is 0 because of the open circuit. In the same current formula, IP is sorry, written once again, IPV is equal to IP minus of I naught e to power VPV plus IPV into RS divided by NVT minus 1 minus of this one VPV plus IPV into RS divided by of shunt resistor. In this condition, VPV is VOC, IPV is 0, and sorry, IPV is 0. It means this will be 0. IP is IP, same photon current. I naught e to power, this will be VOC, this will be 0. This will be a VOC, this will be a shunt resistor. Same thing you can say shunt resistor is very high is respect to open circuit voltage of a cell. Open circuit voltage of a cell PV cell is approximately 0.6 volt because of the silicon PN junction voltages is 0.6 volt. Yes, anyone have some doubts? Anuj Kumar. If you have any doubts, you can write in chat box also. That's why you can neglect this term also. You can neglect this one. Then you can find the output voltage, open circuit voltage. VOC divided by NVT.
सर
Yes,
हेलो
yes, yes.
सर मैंने लेट ज्वाइन किया, पिछला नोट्स मिल जाएगा, पिछला जो आपने करवाया?
अब लेक्चर हम आपको मिल जाएगा, डोंट वरी.
ओके सर.
We will get the lectures of this one on YouTube, I think. And you same thing you can find from this homepage of this one NPTEL, where your course are there. You can go through the interaction session. Then we will get this all of the video, all the session, and I will get the link in next lecture. Don't worry. It yes, yes. This class link is posted in PTL portal also. All the classes you can get the link at NPTEL portal. I think within the week or next week it starts. You can get the access of this one. E to power VOC divided by NVT is equal to IP plus I naught divided by I naught. Sorry. You can take a log, natural log of this one. And VOC NVT are written directly. If you have any doubt, then call IP plus I naught, like that. Arun asking like, sir, do you get the recorded class of this session? Yes, yes, you will get fine. I will give you a link of this session in the next week, month. I think Tuesday. Don't worry. Next Tuesday, I will give you the link of this session.
Okay, next Tuesday, sir.
Yes, yes.
Okay, sir. Thank you, thank you, thank you.
Yeah, if you find the link of this one in NPTEL portal, but you can search there. If you
So,
search
but the thing, the problem is solved over there, or um,
same
just
thing,
about.
same class,
Yes. Okay, sir.
all to all. They,
Okay.
don't worry.
Thank you.
Okay, no problem. There's a NVT ln IP plus I naught divided by of I naught. This is the open circuit voltage of the open circuit voltage a PV cell, and short circuit current is here. I written once again. I written here short circuit current. Right. This will be a directly IP photon current, same as the short circuit current, and open circuit voltage depending on the IP, same thing met in algorithm region. Okay, fine. Let's go for the some numericals and see what is asking there. Question number first, I will take what is the equivalent circuit of an ideal photovoltaic cell? Anyone have doubts of this one? Current source in panel with a diode. Good. A D option. First is given as a voltage source in series with diode. It will be any voltage source have a series diode as no series diode is series resistance. Current source in series with diode. No. Voltage source with an anti-parallel diode. Voltage source with anti-parallel diode. Okay. What happen if it is given like a voltage source with an parallel with a diode? Do you understand of this one? If there is no anti-parallel, only parallel diode, can we connect like that any diode through a voltage source? It will be like a voltage source and a diode connected to the parallel. Can I connect this one? Never. No. It will be a short circuited. Na. If this voltage is increase the blocking voltage of this one any time, then it will be a short circuited. D option is correct. Current source in parallel with a diode. Okay, fine. Like which of the following is true? The two current source can be connected in series, or two voltage source can be connected in series, or both. Anyone? First, go to option one. Two current source can be connected in series. It can be connected in series, or two current source. Someone say B option. Yes, fine. This will be 5 ampere current. This will be suppose 3 ampere current. B option. Yeah, correct. Second was this one. Suppose this one 5 volt. 10 volt. And what is this voltage? And what is this current? I. Option A, option B, like that. Any branch, uh, the current will be same at any branch, anywhere. Current will not be different. Voltage may be different because of the resistor. If you connect a resistor, many resistor in a series, then there will be many voltages. But current will same at all. Someone asks me like share YouTube link of this video or solve PPT of this session. Video and PPT both. I'll give a link. Don't worry. Option A is violation of KCL. Yes. And B is a correct option. Okay, let's go to a forward. This will be taking a time. I think. I think all of you know about this one. You can't be connected to current source in series. If a number of resistances are connected in series and you provide some voltages here, then all the branches current will be same. Current will not different. But voltages at a point has a different voltages because of the resistance. But current will be same to all branches. That's why current never who can connect the two sources in a parallel. Same thing in voltage source or two voltage source can't be connected in parallel. This is also a violation of the case KVL. You can't be connected to different sources like 10 volt, 10 volt, like that. You can't be connected like that. Yeah, this will be a 50 volt. If you suppose connect to 50 volt, then what happened? Or 10 volt, I mean, another is a 15 volt. 10 volt can be connected, but in there is the ideal cases. In ideal cases, you can't be connected. In practical cases, because of the some every voltage source have some resistance, internal resistance. That's why you can be connected in say, parallel also, but same rating to improve to increase the current rating of the whole battery pack. I think somewhere you can see the number of battery are connected in parallel also to increase the current rating or increase the capacity. But a free battery have some resistance, internal resistance. That's why you can connect in parallel. But in ideal cases, you can't be connect a parallel in two different voltages like that. A circulating current flow like that, and this will be a short circuited or overcharged. If a 10 volt battery you charge it's like a 25 volt. Yeah, this equalization like that. That's why. Next one is it is not recommended to connect PV directly to the load. Why? Our PV panel can be connected directly to the load. Then what happened? What is the option? Option is poor voltage regulation. Since PV is current source, PV is voltage source. None of the above. What is characteristic of this one? PV voltage, PV panel is VPB, IPB, VOC, ISC. Okay, fine. Suppose a load have some voltages, requirement of some voltages. Uh, it may be some more than the open circuit voltage of the PV panel also. It will reduce voltages also of this one. Any voltage can be connected. but load have a fixed voltage, operating voltage. You can't be take a variable voltage like that. Any load like a fan, any fan, if you DC fan if we take, then this will be a some range of connected of this one, like 100 to 120 volt, I yeah, 120 volt to 150 volt like that. You can't be exceed the over voltages. If you give a over voltage of to the fan, it will be damaged. That's why there is a poor voltage regulation. Same thing, this one. This voltage varies from 0 to VOC also, like that. If current will increased, then what happened? If current will increase, the voltage will be decreases like that. If current will decrease, then voltage will be increases till to VOC. There's a huge voltage differences. That's why you can't be connect directly to the load. Load have some ranges only. You can't be exceed that range. Any load have some ranges of the voltages, operating voltage. That's why A option is correct. However, some doubts like STD stand for the question variety week one is STC means standard time temperature. STC is taken like a standard temperature, like 25 degrees centigrade, and insulation is 1000 watt per meter square. Take this value. The short circuit current and open circuit voltage of PV cell varies. You know about short circuit current, we derivate this one, it will be IP directly proportional to the insulation. It will same as, you can say this will be same as y is equal to x mx, a straight line passing through origin. This will be a linear scale. If in IP increases, insulation increases, then photon current increases, then short circuit current increases, like that. And the second one is the open circuit voltage. Open circuit voltage is NVT ln IP plus of I naught divided by of I naught. NVT ln, you can say this one be IP I naught minus of 1, sorry, plus of 1. And what is the I naught? I naught is reverse saturation current. It will be in nano current, nano ampere or something in microampere, some microampere only, point something microampere or nanoampere. It will be in nanoampere current. And IP a photon current in it will be in current rating like 1 ampere or 0.5 ampere like that. That's why this value is huge, greater than to 1. Then you can say VOC will be NBT ln of IP divided by of I naught only. You can neglect the term of 1 also, because of this value is very high, IP divided by I naught. Then what is the VOC? VOC is directly proportional to log natural log of IP divided by of I naught. It would logarithm depend on logarithm, like this one. Short circuit current is directly proportional to the solar insulation. It will linearly increases, but in open circuit voltage it will increase very less amount of time, very less, like in logarithm mode. Okay. So what can be inferred about the value of a series resistance and the shunt resistance in a PV cell having a very low fill factor. Fill factor. Fill factor is like a parameter to say the figure of merit of PV cell, like how much PV cell is good and how is bad PV cell. If a fill vector is very high, it maximum is 1. Right? If it is nearly to 1, it means this is PV cell is very good condition. If a fill factor is low, it means the PV cell is very bad. Now this will be PVP, IPV, current characteristic like that, VOC and ISC. In ideal cases, this will be VOC, this will be ISC. Then this point you can say VOC into IOC, sorry ISC. This is the maximum power generated from the of EV cell. And fill factor give the merit of good or bad. This will be a maximum power divided by a maximum voltage at maximum power at that voltage into maximum power at that current divided by a open circuit voltage into short circuit current. If this power you can get from the PV cell, then you can say the fill factor is very high, it will be 1. If VMP is same as the VOC and IMP current which where the power is will be maximum, and open circuit voltage and short circuit current, it will be same VOC AMP. This point you can say maximum voltage, maximum power at this voltage and maximum power at this current. And how it will be bad? Any cell, how can it be bad? How much it will bad? It means some cell characteristic is like that, linear characteristic through the voltages. This characteristic is shown, so that this will be a very bad cell. At that point, you can say this is the short circuit current, this is the open circuit voltage, like that. At this point, how we achieve this point? This point we achieve how is the bed of our cell. It means the shunt current, the maximum current is flowing through a shunt resistor, not flowing through the terminal current. Like that, you know. This will be a cell PV current, cell PV voltage, series resistance, and shunt resistance. Suppose the maximum current is flowing through the shunt resistance, then IPV will be very less. Then in which condition the shunt current is flowing, maximum current is flowing through the shunt resistor? It means there is a shunt resistor is very low, and that condition you can say the maximum current flowing through the shunt resistor. This is the quality of bad quality of a PV cell. Sorry, which were high with the low fill factor value. In this condition, the shunt resistor is very low. Same time, the output voltage is very less. It means the shunt resistor, series resistor is very high. If a series resistor is very high, in that condition, the maximum voltage drop across it only, and you will get the very less amount of voltage at a terminal. That's why this will be VOC. Okay, I written as the VOC1, ISC1. In this condition, series resistor is high. Option D, you can see, if a series resistor is high, then maximum voltage drop across it only. Therefore, terminal voltage will reduced. And if the shunt resistor is low, it means your maximum current, photon current is flowing through it only. Now it's okay, fine. Okay, thank you. Thank you. Thank you. Sorry. Then in the question is asking about the which one is the more effective, short circuit current or open circuit voltage. Then the option you can say change in the VOC will more than the change in short circuit current. Suppose you change in IP like 2 to 5 like that. Then what happened? Is if 5 is directly proportional to the short circuit current directly 2 to 5, it will go from 2 to 5. But in this condition, log 2, what is log 2? ln 2 is only 0.693 and log 5, ln 5 is same thing 1.6 only. It will only 2.5 times. It will increase only 2.5 times with respect to the current. Current will increase suddenly 2 to 5. So, but here is 1.6 only. ln in this condition, VOC is good only 1.6, but current will be a 5 directly. That's why ISC is directly proportional to the insulation. But VOC is directly proportional to the log of insulation. Natural log of insulation. That's why this will be very low, very slow, a very low value if you change in the insulation. That's why you can see in PV panel the voltage very less difference between the insulation from day morning to evening. If you observe the voltages of the PV panel, it's very less differences between them. But current is very quickly. This will be a correct change in the ISC will be more than the change in VOC. As the temperature increases, the efficiency of PV cell. Temperature increases, then what will be effect in on the efficiency? Efficiency is output voltage, output power divided by of input power. Output power depend on two factor, VOC and ISC. Input power depend on the insulation into area. Then what effect of this one? If temperature increase, temperature is not included in the input voltage, input power. Input power is same as the insulation and area of the panel. Then what is effect of ISC? ISC is directly proportional to the photon current, IP. And VOC, equal to IP. VOC is NPT ln IP divided by upper I naught. IP insulation, some a point of temperature, if you increase the temperature, insulation will increase, but very less amount of time. That's why current will be increased. Because of you, if you see there is the semiconductor. There is a semiconductor, na. PV panel is made from the semiconductor like PN junction only. In PN junction, if you temperature will increase or if you increase the junction temperature, then current will flow, current will increasing. But in that same time, depletion that depletion layer will be decreasing. That's why voltage will be decreased. That's why But you can say, you can see here also, the current will be increases or voltage decreases, the efficiency it may be increasing or decreasing. Overall efficiency will be decreasing because of the voltage will be more decreases. Okay, let's complete this one topic. That's then after I will give you some solution. Because the temperature, if temperature increases, then photon current increases. The photon current increases, the short circuit current will be increases in temperature condition. But in voltage condition, then you should find the different differentiate. You have to differentiate of this one with respect to the temperature. NBT of IP will be VOC. It will be, you can say this will be IP minus of ln I naught. If you expand this one, VOC NVT ln of IP minus of ln I naught. VT is no, you know, VT is like a voltage, equivalent voltage of temperature effect on the diode. It will be a T by 11,600. This will be a temperature in Kelvin, and you can say this one also same thing, VOC N into T 11,600 ln of IP minus ln of I naught. Differentiate between with respect to the temperature, same thing also. If you differentiate this one, then what happened? It will be minus of VOC. There are two terms, VOC and T. VOC also varies with respect to T, and temperature is there also. Then it will be a two function. You can differentiate, it will be a 1 and second like that. Wait, I explain more. Into 1 by n into T, like that. This one is the first term, this one is second term. If you differentiate this one first and to second differentiation of 1 by t, what is differentiation of 1 by t? Minus 1 by t square. It will be minus VOC. Then differentiation of this one is 1 divided by n into t square into 1100 plus first and second differentiation 1 divided by n into t divided by 1 by 100 into differentiation of VOC with respect to the time only. This will be very less because of the IP. If insulation increases, temperature increases, IP will increase a very less amount of time, about very less amount. That's why we can neglect of this term also. Then this will be minus of d by dt ln of I naught. This will be nt t by what 11,600 is Vt only. Then mind VOC divided by n into t into Vt plus 1 by n into Vt open circuit voltage divided by temperature. How calculate of this one? Ln of this one. Saturation current I naught know all about k into t power m e to power minus VGO divided by of NVT. Where K is Boltzmann constant, T is temperature, VGO is forbidden energy gap, electron volt, and VT is know, all of you know about the equivalent voltage of temperature. And M is like a metallic form of metal like 1.5 for the silicon. N is the ideality factor. It will be 2 for the silicon. In all, you can say so K is temperature, M and N is the constant only. Then you can take log both side. Then you can take ln of K into plus M ln of T minus of E log ln of E to power something is VGO divided by of NVT, and VT is T divided by 11,600. Then you can differentiate all with respect to the temperature. K is the constant and it will be 0. M ln T is differentiation with respect to time is T equals to is 1 by T. Same thing, this one will be the Vt. Vt is T1000 divided by T divided by 111 2000. Yeah, temperature in Kelvin only. If you take a Kelvin, then take a Kelvin for all condition. If you take in degree centigrade, then take a degree centigrade in all the condition. And maximum time, this will be Kelvin only. This will be equal to T by 11 to 600. You can difference 1 by T like that. Then 1 by VGO is constant because of the forbidding gap in energy of electron. Silicon is 1.16 to 1.2 only. This will be constant. N will be constant. Vt is T divided by 11 2000. If we differentiate, 1 by T is minus of 1 by T square. Then minus will be positive divided by of N into T square divided by 1 600, and d by dt y naught m divided by T plus VGO divided by of N into T into Vt. In 1 T, if you take a common, then T divided by 111 600 is Vt only. Same thing we can put here, minus of VOC NT into Vt plus 1 divided by NVT dVOC divided by dt. You have to find the VOC divided dVOC with respect to the time, change in the VOC with respect to the time. Then minus goes to here, m by T minus of VGO divided by of NT into Vt. VOC T minus of m into N Vt plus VGO. We take a common this one, then it will be a m n Vt divided by VGO minus we take a common here, then it will be plus mn m into N into Vt plus VGO divided by T. And VGO, if you multiply of this one and Vt, it will be cancelled out, N into Vt in both the cases. That's why VOC Vt is equal to VOC minus of m n into Vt plus VGO open circuit voltage of a cell is very less, like 0.6 volt for silicon. A PN junction diode like 0.6 volt. M and M is 1.5 for silicon, 2 M is 2 for silicon. Vt is the temperature coefficient voltage, like Vt by I T by T by 11,000 plus VGO. VGO is 1.16 something. Then the whole the value of this one will be greater than this one. That's why the overall temperature coefficient will be a negative. That's why temperature will, if you increase the temperature, then open circuit voltage will decrease. And same thing, if you say like in theory model, if you increase the temperature, then depletion layer will decreases. Then depletion layer will decreases. That means the voltage will be decreases of the depletion layer of any p-n junction diode. Then voltage will decrease when increase the temperature. But in this condition, the voltage will more decrease with respect to the current increasing. Current is increasing some amount, but voltage will be more decreases respect to the current. That's why the overall efficiency of the CP cell will be decreases, and the temperature will increases. That's why the option number after option 1 is correct. Efficiency will decreases. The module efficiency of a PV panel tested under a standard condition of an insulation like 1000 watt per meter square and temperature is 25 degrees centigrade is 20%. Efficiency is given 20% at a standard calculation like insulation of 1000 watt and 25 degrees centigrade. This is the standard parameter. The panel, which is area of 2 meter per square, is operational in a region where the present insulation is 400 watt per meter square only. Assuming the panel temperature to be the same as the standard temperature, the maximum power output during the present condition. They are asking about the maximum power output when the insulation is reduces to 400 watt per meter square. First, calculate the input power at this condition. We know about the efficiency. Efficiency is output power divided by of input power. And what is the output power? Efficiency into input power. Input power is insulation into area. Insulation is given as 1000 watt per meter square and area is given as 2 meter per square. It will be 2000. The efficiency is 20%. The 20% of 2000 will 400 watt. Then what is in second condition given as the only when 400 watt. Then what is the P input? P input is insulation into area. Area is the same. Insulation is 400 watt per meter square. Area is 2. It will be 800 watt. Input power. Then what is the output power? Same thing. Efficiency into input power. Efficiency is 20% into 8. It will be 160 watt. This will only. As the intensity of light incidence on a PV cell increases, then IV characteristic of a cell moves towards the right, towards the left, towards the upwards and downwards. As the intensity of light incidence on PV cell is increases, it means insulation will increase. If insulation increases, then what happens? Voltage will increases and current will increases, and current will be directly proportional to the insulation, and voltage voltage is directly proportional to the logarithm of insulation. Then it means the short circuit current is increases more and open circuit voltage increases but in less value. VPV, IPV. This will be the first condition, VOC and ISC. What happens if you increase the insulation? Then short circuit current increases. Suppose this value, but same time if you suppose insulation increases like a 5 value 5 unit, then what happened in this condition? In logarithmic condition, log of 5 is 1.6 only, but current will increase 5, but voltage will increase only 1.6 volt. That's why this will be looks like this one. Same thing if you increase more, then this will be shifted like that. Sorry. From this one you can say the whole curve is shifted towards the upward only. In what condition it will shift in the rightward? Rightward means current will increase very less, voltage increase more. Like this one, this type of shape. This type of shape you can say this will be a moves to the right and left moves, it means voltage will be decreasing. When voltage decreasing, then all the curves move towards the left. Down shifted, it means the current will be decreases. So current decreases like that, then current decreases to the go to the downwards. But in this condition, insulation will increases, then current will more increase, voltage will increases, but not in same as respect to the current. That's why all the whole the curves move towards the upward. Data sheet of a solar panel manufactured by a company named Loom Solar is given. The total number of monocrystalline per cell in the solar panel described in this data sheet. Here you can say this one is the 144 cell is there. This is the data sheet of any cell, PV cell panel, a solar module like that. In a module, a large number of cells are connected in series and parallel. But in this data sheet is given as this is the 1500 volt DC and 20.2% of maximum efficiency. Then monocrystalline material is given and 144 cells are there. 144 cells in this panel. Yes. Which one? Danus, have any doubts? There is a 144 cells in a module is given, and you can say you can see all of the specification qualification like that. IC it means the verified by the all of the standard organization also, ISO 1001, ISO 14001, like that. Here is the data sheet of electrical data sheet. Electrical STC, it means the at a standard time, standard value like irradiance of 1000 watt per meter square, temperature 25 degrees centigrade, air mass it will be at like 1.5 only, sorry 1.5. At that condition it will given like maximum power 44 440 watt, a maximum power at that voltage, which voltage is 42 volt, and maximum power in that maximum peak current is 13.5 ampere, open circuit voltage is 50 volt, and short circuit current is 11.35 ampere. If module efficiency is 20.2, it will be at a standard condition like irradiance of 1000 watt per meter square, cell temperature is 25 degrees centigrade. But in not the practical cases is the same thing. In practical cases, if you keep a solar panel in sunlight, then it will be heat up sometime. After some time, it will be heat up. If the heat, it means the temperature will increases, and temperature increases, it means power will be decreases. Current will increase sometime, but voltage will more decreases. That's why. But this condition is given as the standard condition. Follow the standard condition, then you will get the that much of power. This one further non-standard like 800 watt per meter square and 20 degrees centigrade, wind speed of 1 meter per second. Then given as the you can say the maximum power is 323 only. It decreases. Previously is 440 watt, but here is maximum power only 323 because of 800 watt per meter square. Insulation irradiance. VMP sorry, voltages at maximum power is 38 volt, and current at maximum power is 8.55 ampere. Open circuit voltage is 46 volt. We can say this when the open circuit voltage is not too much decreases, like 50 volt only, there's 46 volt only or 856. Temperature is given coefficient. We can see here temperature coefficient clearly given. For the short circuit current, it will be positive, but in open circuit voltage, it will be negative. If the open circuit voltage is negative, current is positive, then power definitely negative. Multiplication of this one only. Maximum system voltage 1500 volt. This is the mechanical data. Mechanical data means how much numbers are there. 144. There is a 144. 12 into 6. 12 into 6. It means there is a 2 parallel thing. 12 into 6 parallel to the 12 into 6. Total is 144. Total minus weight, all of thing is given there. You can follow this one. And question first asking about the number of cells connected in this finally. So there is the total number of cells in the solar panel is 144. From same data sheet given the previous question, percentage model efficiency. Percentage model efficiency 20.2% at a standard condition is given also in the question. Standard condition, what is the percentage model efficiency? Is 20.2% only. Same. Now the mechanical data section for the data sheet, they given in the previous question, calculate the panel efficiency. Panel efficiency, you know about panel efficiency is output power divided by of input power. Output power you will get the VMP into IMP. Input power is insulation into area. How calculate the area or module area into number of cells or cells area and number of cells. Total 144 cells. Then what is the cells area? Cell type is given as 166 into 83 meter square. Sorry, mm square. 166 into 83 per cell area. 166 into 83. This is the area and this is the number of cells connected in a final. Because of here asking about the final efficiency. This will be in mm. We calculate convert in the meter. Then you have to multiplication of 1 minus 6 10 to power minus 6. To calculate all of things, it will be like 1.298 meter per square. Then input power. Input power is and standard condition is 1000 insulation, 1000 watt per meter square, and area is 1.98. Total is 1980 watt. Maximum power is given already 440 watt. In standard condition is the 440 watt is given as the maximum output power. Then efficiency is 440 watt divided by 1980. It will be coming it's like a 2.2222. Then in percentage, multiplication of 100, same thing, is 22.22%. What is the minimum fill factor of solar PV module at temperature of 25 degrees centigrade from the given data sheet? Minimum fill factor. Minimum fill factor, it means fill factor is the output power VM IM divided by a VOC and ISC. Fill factor is the VMP into IMP divided by of VOC into ISC. Minimum and what into what condition is the output voltage will be minimum. The given is the 25 degrees centigrade. The maximum power is given as in variable of plus 5 to minus 3%. It will increase is 5 watt, but decrease in minus 3%. P maximum is given 275 plus of 5 watt or 275 decreasing up 3%. It given as the fill factor is minimum fill factor. It means the minimum output power. The minimum output power is coming into this section. 275 reducing up 3%. It means 97% of overall. It will be the 100%. Then minus of 3% is 97%. I think this will be 266. I think something. What? And 266.75. VOC, IOC, VOC is given in this question 38.6, ISC is 9.48. You can calculate the efficiency of fill factor. Zero point 0.7289, approximately 0.73. Calculate the open circuit voltage and short circuit current for the data given in question 6 at the temperature of 45 degrees centigrade. Okay. Temperature coefficient is given, output voltage is minus of 1.37 into 10 to power minus 1 volt per centigrade. And short circuit current is given 5.5 into 10 to power minus 3 ampere per degree centigrade. Standard is the 25 degree centigrade. Now temperature is 45 degree centigrade. Then what is the new VOC? First we can calculate the short circuit current. T1 is 25 degree centigrade and T2 is 40 degree centigrade. Then temperature difference is 15 degree centigrade. ISC2 you can say ISC1 plus of delta I. Sorry, 45 degree centigrade. It means this will be a 20 degree centigrade. Okay. Thank you. First condition ISC is given as 9.48 ampere plus of 5.56 into 10 to power minus 3. Nine point 48 plus 5.56 into 10 to power minus 3 into temperature difference is 20 degree centigrade. And what is the final current? Nine point 59 ampere. Same thing for the voltages. Open circuit voltage is open circuit voltage minus of delta V. Yeah, plus of delta V you can say. There is the negative temperature, negative coefficient, and will also reduces. VOC is 38.6 volt and minus 1.37 into 10 to the power minus 1 volt per centigrade. Minus 1.37 into 10 to the power minus 1 into per degree centigrade, there is a 20 degree centigrade differences between them. It will be 35.86 volt. I think this is the first option. Next question is given as a PV panel has an open circuit voltage of 40 volt and a short circuit current of 8 ampere at 25 degrees centigrade. The temperature has become 40 degrees centigrade. Each PN junction develops an open circuit potential of 0.6 volt and it decreases by 2 millivolt for every degree increases in temperature. The open circuit voltage is now approximately. You all want to solve this question? I can give you 2 minutes to solve this question. Anyone? Please solve and tell me what's the answer. This one. Panel voltage is given. And current, short circuit current is given. You can say this one is the VOC of panel. Short circuit current is given of panel 8 ampere at T1 is equal to 25 degrees centigrade. Now it says that each PN junction develops an open circuit potential of 0.6 volt and it decreases by 2 millivolt for every degree increases in temperature. What is the delta V? Sorry, first complete the word delta T. Delta T is now 40 degrees centigrade minus 25 is equal to 15 degrees centigrade. And what is the delta V? The V is given by 2 volt, 2 millivolt, 2 into 10 to power minus 3 for every decreasing in temperature in every degree. 0.03 volt. And what is the output voltage? Nu. Okay, let's complete this one. There is not given the how many number of cells are connected in panel. But it is given directly the open circuit voltage of a panel is 40 volt. And it also mentions that each PN junction develops an open circuit potential of 0.6 volt. Then first you have to calculate the how many numbers of cells are connected in series or parallel like that. Then there is a 40 volt. First to connect number of cells. Forty divided by a 0.6 volt per for the per cells. There is 66.67. Now the changes of this voltage is 0.03 volt. Then previously is 0.6 volt. Then now what is the number of cells voltages of this per cells? VOC of cells is equal to 0.6 minus 0.03. 0.57 volt. Then now now VOC of the panel. $80.0019, it will be a 80 volt. VOC2 you can say this will be 38 volt, sorry, 38 volt. What is the insulation level in watt per meter square for a module? Efficiency of 15% and the maximum output power of 198 watt. Area of the module is also given. All of know about the efficiency is output power divided by input power. This will be maximum power, and P in is insulation area. First calculate the area. 1662 into 990 mm square, then multiply simply 10 to power minus 6 to convert into meter square. This will be 1.645 meter square. Then insulation you can calculate from here. Efficiency into area output power efficiency into area. Output power is given 198. Efficiency is 15%, it means 0.15. Area is 1.1645. $82.24 watt per meter square. Question asking in watt per meter square. That's why you have to convert this one in mm square to the meter square. A photovoltaic cell of a solar PV module has a following data. Diode saturation current is given is 1 nanoampere. Diode saturation current, you know about diode current. First, so ID is equal to I naught e to the power Vd divided of nVt minus 1, where I naught is the reverse saturation current. then I naught is given as 1 nanoampere. It means 1 into 10 to power minus of 9 ampere. Second equal volt equivalent of temperature. It means Vt, volt equivalent of temperature. T divided by 11 into 600 with temperature in Kelvin is also mentioned. Photo current of 8.6 ampere. Photo current it means IP 8.6 ampere. And diode ideality factor N also given. N is equal to 1.4. If there are 60 number of cells are connected in series in a one module, then what is the open circuit voltage of a module in volt? Sorry. Another information also given is a photo current is much higher than the current flowing through the shunt resistance. Open circuit voltage is equal to NVT ln IP plus I naught divided by R of I naught. IP is much more than this one. This only shunt current is given to photon current. IP is very less than the ISS. That's why you can neglect that terms to when I found the open circuit voltage. Na, that's condition is neglect of this one. In starting is this one. I neglect this term. Yeah, VOC because of the IP dependent on the VOC. IP very high with respect to the shunt current. That's why I neglect of this one whole term. You can calculate all of them is given. Then what VOC, N is given 1.4, VT is given, T divided by 11,600. In normal temperature, you can see this is not mentioned temperature here. You can see the photovoltaic cell, our PV module has following data: diode reverse saturation current is 1 milliampere, 1 nanoampere. Volt equivalent of temperature is T divided by 11,600, where T is the temperature in Kelvin. Photo current of 8.6 ampere and diode ideality factor is 1.4. There are 16 numbers cell connected in series. They want one module. Then what is the open circuit voltage of the module in volt? Vt is equal to T divided by 11,600. Can calculate at room temperature. Room temperature, this will be 300 degree Kelvin. And what is the Vt? Approximate 26 millivolt at a room temperature. Then we can put here 26 millivolt. IP is given and 8.6 ampere plus 1 into 10 to power minus 9 nanoampere. So if you calculate this one, then you will get the value of this one is 0.8326 volt. Then 60 number of cells are connected in series to make a module. Then total VOC is equal to 60 into 0.8326. Total is equal to 49.959, approximately 50 volt. Okay, everyone. Thank you. I want to stopping here. If you have any doubts, then you can give me a comment. Rather, I want to finish all.
I think answer may be not tallied with the given answer there. It was mentioned as 46 something, right?
46 to 54.
Okay. In one more doubt is
Yes.
I naught should be taken in microamperes.
Which one? Current
I
saturation.
naught. I naught. For
I not already give a mention is 1 nanoampere. That's why.
nanoamperes, but as per the standard, I think they need to consider in microamperes. That is my question. Uh,
Yeah, if you mention in the question, then you can take same thing.
uh, Not in
All
the question. That as a standard in
standard
the
is in micro to nanoampere
okay.
saturation current. Okay.
Okay.